Grade 12s, let us continue to propel the activity of preparations for the final examinations. Now, before we can get into the task at hand, the task of understanding the geniusness of IUPAC naming of alkynes, allow me to give you a food for thought. You must fully be aware of the actuality that you don't have to be a genius, you don't have to be an intelligent learner to achieve level 6 or a distinction. It doesn't only take a genius or an intelligent learner to achieve a distinction or a level 6. All you have to do is to ensure that whenever you walk into the examination room, you walk there with an extensive exam orientated knowledge. That is what it takes. That is the criterion that you need to have in order to achieve a level 6 and a distinction. And if you want to have that extensive exam orientated knowledge, you must be able to study with NETA, so that NETA can be able to ensure that we instill it in your mind with the objective that you achieve level 6 or level 7. NETA is here to study with you. You should be able to, you cannot fold your arms and say that you've been studying from term 1 to date and you've been performing on poor performances. It cannot be while NETA is here that we allow that nonsense of performing in poor performances. Now you should study with NETA so that NETA can be able to uplift and catapult your results to the level of your satisfaction. Now let us get into the task at hand. We are dealing with alkynes. And one thing about alkynes that should duly be noted is the actuality that alkynes are said to be unsaturated compounds. What that means is that they are compounds that contains double or multiple bonds. They contain multiple bonds. So they never contain a single bond. They contain more than a single bond. That is why they are said to be unsaturated. And another thing that should be well noted about alkynes is that their general formula is CnH2n-2. Now this is the general formula that all alkynes adhere to. All alkynes adhere to this general formula, and we will see that during the course of the video. Now, our alkynes have the functional group, the structural formula of the functional group of this this manner. This is the structural formula of the functional group of alkynes. You can see that they have triple bonds. That is why they are said to be unsaturated. Now, remember that anytime you engage yourself in the activity of the IUPAC naming, there are few principles that you should never afford the luxury of avoiding. It is the principle that governs and that tells the story of the number of carbons that are available in your structural formula. Now, in the case where we have one carbon, the prefix which is used to indicate and demonstrate the availability of one carbon is meth. And when we have two, we will use eth. When there are 3 carbons, prop will be used. When we have 4 carbons, we will use the prefix of bute, where 5 carbons will be indicated by pent and 6 carbons will be indicated by hex. And because we are dealing with alkynes, I'm telling you, we're going to need more than 6 carbons. We're going to be dealing with 7 carbons, which is hept. Now let us look into the naming of the following structural formula. And remember that your carbon is always bonded to, it always has 4 bonds around it. You must ensure that the bonds around the carbons are always 4 of them. So we have 1, 2, 3, 4 around this one, and 1, 2, 3, 4 around this carbon. So that we never make we don't commit the error of misrepresenting the bonds that should be presented in the structural formula. Now, how do you name this alkyne? You can see that this alkyne contains 2 carbons, and we know that when it contains 2 carbon, it is represented by the prefix of eth. Therefore, this will be called ethyne. And the same thing will go to a carbon with 3, a structural formula with 3 carbons. This is our functional group. Okay, let me redraw it. Yes. Let me redraw it. Now, this will be named propyne because it has 3 carbons, and 3 carbons are represented by the prefix of prop. So this prop means that we have 3 carbons, and it can also be shaped in this manner. Because remember, when we count, we start to count from our functional group. In this structural formula, this is our functional group. It means our counting will start from this point towards that direction. And in the structural formula, our counting will start from this point towards that direction. So we're going to say 1, 2, 3. We still have 3 carbons. So it is still it is still called propyne. Now I want you to put on your listening ears because now the tables are about to turn. It's about to get a lot more complicated than the first 2. We have a situation where we have to account for the position of our functional group. These triple bonds must be accounted in terms of their position. So I need you to put on your listening ears and listen carefully to how this structural formula is to be named. Now remember, the first thing that we have to establish is the number of carbons that are present. Now, how many carbons do we have? 1, 2, 3, 4. And when we have 4 carbon, we know that it will be represented by but. But is the prefix that is eligible in the representation of 4 carbons. Now, because we have 4 carbons and we have to account for the position where this functional group is situated. Now we're going to say but because our carbons are found or have been established to be 4 of them, which is this but is the representation of the actuality that we have 4 carbons. Now, the second thing that we have to do is that we have to account for this structural formula. These triple bonds must be indicated its position. You can see that it is situated in the first carbon. From the first carbon is where we have our triple bond. We have to show that here that this is where it is situated with the first carbon. And then YN is the representation and the actuality that we are dealing with alkynes. Now, this structural formula is but 1 YN. That is how we deal with the structure, the IUPAC naming of the structural formula. Now, this, let me repeat this one. So this is indication of the number of carbons, and this one shows the homologous series of alkynes, because we are dealing with alkynes, and this is the position position to which the triple bond is situated. Now this is how we name our structural formula. In the instance where you might have missed or you might have not understood, the triple is P, not B. It's triple, not triple. In the case where you might have misunderstood everything that has been going on throughout the course of this lesson, please submit all of your misunderstanding and confusions to Netta and study with Netta so that we can be able to put all effort into pushing you to level 6 or a distinction. It can be done. It is doable when you study with Netta.